7.1, the probability, the learning target. Understand how the probability of an event indicates its likelihood. Success criteria. I can find the sample space of an experiment. I can use probability and relative frequency to describe the likelihood of an event. And I can use relative frequency to make predictions. All right, so the first investigation. You win a game if you correctly guess which color you will spin of the spinner shown. Which color would you choose? Explain. So hopefully looking at this, you would say, oh, I would choose the blue. Why would I choose the blue? Well, I would say the blue has a bigger area than the red. So the blue has a bigger area than the red. All right, number 2. You spin a spinner 30 times and record the results. Okay, let's go ahead. I've already done this. So I made a table of the values. So we spin, we can get a blue, or we can spin and we can get a red. Okay, I did this experiment, and what I found out is I spun a blue this many times. I spun a red this many times. So if we go ahead and we count them up, according to my results, does the data support my choice? And I would say yes, because we spun the color blue more than we chose or spun the color red. All right, number 4. You spin one of the spinners below 30 times and record the results in the table. Which spinner do you think you might have used? Explain your reasoning. So if we know that we spun the spinner 30 times, if we did blue was 14 out of 30, and the red was a 16 out of 30. Hopefully, if you notice, would you agree that both of these are close to 1/2? So which ones look like they're close to 1/2? And that would be the one here in the top left corner. Okay. Key concept. Outcomes and events. An experiment is an investigation or the procedure that is verifying the results. Okay, the sample space of the experiment is the set of all possible results or the outcomes of the experiment. A collection of one or more outcomes is known as an event. The outcome is a specific event called the favorable outcome. So, for example, randomly choosing a marble from the group of marbles is an experiment. Each marble in the group is an outcome. So if you take a look, you see our sample space with the different colored marbles. The event of choosing a green marble, well, there are a number of favorable outcomes for choosing a green marble is just 2. All right, example number 1. You spin a spinner and find the sample space. How many possible outcomes are there? So if we're looking at example number 2, identify outcomes. You spin a spinner. You find the sample space. Find the sample space. How many possible outcomes are there? So if we look over at the side here, we would see that we have our spinner, and we have a 1, a 2, a 1, a 3, a 4, and a 1. So we would say that our sample space is a set of all possible outcomes. So that would be our highlighted here. 1, 2, 1, 3, 4, and 1. So that tells us that there are 6 possible outcomes. All right, part B. In how many ways can spinning the number less than 2 occur? So if you think about the numbers less than 2, the only number that's less than 2 would be right here, right? The number less than 2 would be spinning a 1. Not less than 2, those would be values 2, 3, and 4. So the favorable outcome of spinning a number less than 2 are 1, 1, and 1. So what we would say is, so spinning a number less than 2 can occur in 3 different ways. All right, you randomly choose one of the tiles from the hat. Okay, find the sample space. So the sample space is just going to be our letters. So we have A, we have D, B, B, C, oops, B again, E, and A. Now, how many possible outcomes are there? Well, let's count them. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8. So we would say that we have 8 possible outcomes. In how many ways can choosing a vowel occur? Well, the vowel here would be A, an E, and we have an A. So we would say that there are 3 ways of choosing a vowel. All right, so that's the first group of examples here. So please circle 1, I don't understand yet. 2, I can do it with some help. 3, I can do it on my own. Or 4, I can teach someone. All right, so now we have our key concept. So the probability of an event is a number that represents the likelihood that the event will occur. Probabilities are going to be between the numbers 0 and 1, including 0, 1. Probabilities can be written as fractions, decimals, or percents. So as we take a look at this, we would see that we have a nice little number line here, right? And on this number line, we start here, we go all the way down here. Down here, this is impossible. It's impossible is 0. If it's going to happen, that's certain, that's 100%. So if we take a look at the percents, impossible is 0%, certain is 100%. Now, right smack dab in the middle, you see we have the fraction 1/2. 1/2 as a decimal is 5/10, and as a percent is 50%. So like it said up above, you can write it as a fraction, decimal, percent. So when we look at these values here, we say that these are equally likely to happen or not happen. So think of it as 50-50. And then in between, values that are greater than 1/2 but less than 1 fall right in here. Those are likely. So examples that they have here are 3/4, 75/100, and 75%. And values that are less than 1/2 but greater than 0, those are the ones that are unlikely. So 1/4, 25/100, or 25%. Okay? So if it's certain, that's 100%. As a decimal, that's 1. If it's impossible, no way that it's going to happen, that's 0% or 0. In the middle, likely to happen or not happen, 1/2, 50%. And then somewhere in the between, impossible and likely as happen and not happen is unlikely, and greater than 1/2 but less than certain is or likely. All right, let's take a look. Now, what do we have here? The chance of rain, thunderstorms, hail, and high winds today are shown. So you can see them over here. So the first thing it says here is describe the likelihood that So let's take a look at the in-class practice. So what is the probability that you land a jump on a skateboard is the fraction 1/10. Describe the likelihood of this event. So if we think about our number line again, remember our number line? Okay, it's certain, it's 1. If it's impossible, it's 0. If it's likely to happen or not happen is 1/2. And if we look over here, we would see that 1/10 would be right here. So looking at this point right here, I would say that this is in the unlikely range. It is unlikely that the skateboarder will land the jump. All right, self-assessment, 1, 2, 3, or 4. How do you feel about this part right here? Okay. The display shows the data of recent baseball season. An outfielder has to run 80 feet to catch a ball with a hang time of 6 seconds. Describe the likelihood the outfielder will catch the ball. So how likely will this be? So as we are looking at our margins here, so here we have the distance that the outfielder must run, and over here we have the hang time in seconds. So according to our information here, we have 80 feet, run 80 feet to catch the ball, so that would be right about here, and the hang time is 6 seconds, which is right here. So if we draw our line up and over, we could see that it's somewhere in this area right there of this representing the foul balls to the outfield. So down in the right corner here, catch probability, noticing the different colors. So if we look at this one right here, that's kind of in this range, pretty close to 100%. So since it's pretty close to 100%, I would say that this one here would be likely to happen. Okay. The data shows the data of a penalty kicks on a soccer league. Describe the location of the penalty kicks that is likely to be successful. So we want to score the ball. So as we look at the margin here, we have the probability of success. So the blue, almost impossible. Up here, 90%, that's pretty high probability. So what we are doing is we're looking for anything that's in the orange or dark red. I would say anything in the orange or dark red is going to be likely to happen, okay? Because we want anything above 50%, right? And the ones that are more likely is going to be here. So I would say maybe on the left side, the right side, and maybe across the top. Any of those spots, right? So anything over here, or anything across the top, it's likely that they will score on the penalty kick. All right. Self-assess, 1, 2, 3, or 4. How do you feel about that one? All right. So when you conduct an experiment, the relative frequency of an event is a fraction, or percent, the time that an event E occurs. So we want to make sure we know that. So it is a fraction or percent of the time that occurs. So this is what we're going to be using right now. So the relative frequency is the number of times that the event occurs over the total number of times you conduct the experiment. So how many times the event occurs over the total number. All right, this one's kind of all worked out for us, so we'll just kind of read through this. So each turn in a game, you randomly draw a card from a box and replace it. The table shows the number of times you draw a card of each type of card. How many times can you expect to draw a fungi or an animal card in 35 times? So we're looking for the fungi or the animal. So the card, here's our fungi card. Here is the animal cards, and that's how many times it was selected out of 35. So, reading along, the relative frequency that the card drawing a fungi or an animal is, here's our relative frequency again, right? It's the number of times the event occurs over the total times that you conduct the experiment. So, if we look up above here, we have the fungi was collected, 10 times? The animal was 3 times. So if we add them together, that's how we get our 13. And how many total times did they draw? Well, in order to do that, we needed to add up how many tally marks we have. So we have 5, 10, 15, 16, 17, 18, 19, 20. So that's how we got our 10 plus 3 over 20, gives me 13 over 20. Changing our fraction to a percent gives us 65%. Okay, so if it's 65%, the event is likely. So in 65% of 35 terms, you will expect to draw fungi of the animal. So what they want us to do next is they want us to find what is 65% of 30. So they say A equals P% times W. We write the percent of the equation. We change the 65% to 0.65. We multiply it by 35. And when we multiply, we get 22.7. Another way to let's try that again. Another way to find 65% of 35 is to set up a proportion. So we use the is over of equals percent over 100. So we go is over of equals your percent over 100. So we have is over of equals my percent, which is 65 over 100. And then if we solve this using cross multiplication, we would see that when we multiply this way, 100 times x is 100x. If we multiply 35 times 65, that gives me 2,275. We would divide both sides by 100. And when we do, we get the same value as before. X equals 22.75. So in either case, that's how you could tell it. All right, let's take a look at the in-class practice number 4. It says each day of the 3 weeks you record whether or not there will be a pop quiz. How many days can you expect to have a pop quiz during the 180-day school year? So if we take a look at what we have, so we would see that we have 2 days we have a pop quiz, and we have 13 days that we do not have a pop quiz. So if I add them together, 2 plus 13, we know that 15 is going to be the total. All right, come on, pen, work. All right, so to find the relative frequency, to find the relative frequency, it is how many times did the pop quiz occur over how many times did it happen total. So from up above, we knew we took the pop quiz 2 times out of the total, which we have right here, is 15. So if I were to change that to a percent, we would say that it's about 13%. So that's kind of like it would be unlikely. So now they want us to do the second part here, and they want us to know, well, during a 180-day school week, how many times would you expect a pop quiz? Well, we know 2 out of 15 days we're going to have a pop quiz. So now we got to figure out how many out of 180. All right, so we'll set up our cross multiplication here again. So 15 times x is 15x. 2 times 180 is 360. Use inverse operations, divide both sides by 15. 360 divided by 15 is 24, so that would tell us that it would take 24 days. So 24 days in the 180 days, you would expect to have a pop quiz. All right, so the last thing we're going to do is we're going to finish up with the summary. So the summary, to find the probability of an event, we'll write this. So probability of the event is the number of times the event occurs. How many times over the total number of times you conduct the experiment. All right, so after you have completed writing the summary, feel free to upload your notes and submit in Canvas. Thanks so much. Bye.